All right, welcome back to Die Hard American Metal. Today we are talking about a piece of technology that is, and I'm not exaggerating here, a complete game changer. It's giving American shops the power to stamp parts with the precision you'd expect from a high-end CNC machine. Let's get right into it.
You know, for as long as we've been making things in this country, every single shop has faced this choice, right? On one side, you've got CNC machining. It's the gold standard for precision. You can make unbelievably complex parts, but my gosh, is it slow. And the waste? You're often turning more than half of a very expensive block of metal into chips you gotta sweep off the floor. Then, on the other side, you got traditional stamping, the absolute king of speed. Just banging out parts every second with almost no waste. But the trade-off has always been precision for speed.
For decades, you just had to pick your poison. You could have it perfect, or you could have it fast. You could never, ever have both. But what if that whole idea, that entire compromise that's defined manufacturing for so long, just vanished?
So first, let's really dig into this precision gap. We need to understand why it was even a thing, and how it really hamstrung American manufacturing by forcing engineers and designers to choose between two imperfect options.
Okay, so you've got subtractive manufacturing, what we all know as machining. It's like a sculptor with a chisel, just carving away everything that isn't the final part. If you need a critical part for a fighter jet, with tolerances so tight you can't even see them, this is how you do it. But that perfection costs you. It costs you in time, and it costs you a mountain of expensive scrap metal. It's just not practical for high-volume production.
And on the flip side is formative manufacturing, or stamping. This is the absolute engine of American mass production. Instead of cutting metal away, it uses thousands of tons of force to shape it. It's all about raw power and blinding speed. But historically, that power was kind of like a sledgehammer. Super effective for simple jobs, but it just didn't have the finesse, the fine control you need for those really complex, high-precision parts.
And that right there brings us to the technology that just completely shatters that old compromise. This is where the whole game changes.
I mean, just look at the evolution here. It's so clear. The old mechanical press, that was your speed demon, but it was basically a one-trick pony. Then the hydraulic press came along and gave us awesome flexibility and full power through the stroke, but man, was it slow. The servo press, it takes the speed of the mechanical, grabs the flexibility of the hydraulic, and then adds the one thing neither of them ever had. A digital brain.
So what the heck is it? Well, to put it simply, a servo press just tosses out all the old school stuff, the giant flywheel, the clutch, the messy hydraulic pumps. It's powered directly by massive, high-torque servo motors that are all driven by software. It's a stamping press with the mind of a CNC machine. You're replacing brute force with intelligent, totally programmable control.
And this chart just lays it all out. When it comes to controlling speed, the servo is completely programmable. You can change it mid-stroke. Precision? We're talking plus or minus 0.01 millimeters. That is machined-level accuracy, right out of a press. And on top of all that, it's way more energy efficient because it only uses power when it's actually doing work. It's not just a little better in one area. It dominates across the entire board.
But how? How does it actually do all this stuff? Let's break down the specific features that give the servo press these, frankly, unbelievable capabilities. The single biggest game changer is, without a doubt, the programmable slide. See, a traditional press just slams down into the metal at top speed. A servo press, though, can be programmed to come down fast, then slow to a crawl right at the moment it makes contact. This gives those tougher materials, like high-strength steels and modern aluminum alloys, time to actually flow into the die without cracking or tearing. It's intelligence, not just brute impact.
And then you have this thing called dwell. This is the servo's secret weapon against springback, which is the bane of every stamper's existence. After the part is formed, the press can actually pause just for milliseconds at the bottom of the stroke, holding full tonnage. This sets the metal's memory, and it basically eliminates the material's desire to spring back to its old shape. The result? Parts that hold their dimensions with incredible accuracy.
But it's not all about slowing down. This machine has an insane mode for pure raw speed. It's called pendulum motion. For shallower parts, instead of doing a full up and down stroke, the press makes these short, super fast oscillating strokes. It cuts out all the wasted motion and can boost your output by up to 60%. It is an absolute beast of productivity when you need it to be.
So, what does all this incredible control actually unlock? Well, it unlocks the ability to start stamping materials that not too long ago were considered unformable in any kind of high-speed process.
Yeah, we are talking about the really high-tech stuff that defines modern manufacturing. The advanced high-strength steels that make our cars stronger and safer, the lightweight aluminum alloys you need for electric vehicle battery trays, even the titanium and superalloys that are essential for the next generation of aerospace. Servo technology makes it possible to form the materials of the future, today, with speed and precision.
Look, this is more than just some cool engineering. This is an economic revolution. Let's talk about the real-world, bottom-line impact this has for American shops that are out there fighting every day to compete and win.
Just look at this. The cost difference is staggering. When you can take a part that was being machined and convert it to servo stamping, you're not just saving a few pennies here and there. You are fundamentally rewriting the entire cost structure of that part. This is the kind of massive cost reduction that makes American manufacturing a global powerhouse. And a huge piece of that savings comes from material. Machining, like we said, can waste more than half of an expensive block of metal. Stamping is a near net shape process. That means you could see a 90% reduction in material waste. You're no longer paying top dollar for advanced alloys just to turn them into scrap.
And get this, with a single progressive die in a servo press, you can form, drill, tap, bend, and coin a part in one hit. Think about that. You're eliminating entire departments' worth of secondary ops. That streamlines your whole workflow. It slashes lead times, and it saves a ton of money on labor and moving parts around the shop.
And don't for a second think this is some niche, futuristic technology. The biggest, most demanding industries on the planet are leading this charge. Automotive, which is under incredible pressure for lightweighting and building safer cars, makes up over 60% of the market. They are all in because this tech flat out delivers results.
So let's just be crystal clear about this. This isn't just another machine you buy for the shop floor. This is a weapon for American manufacturing. You get stronger parts because of work hardening. You get ridiculously faster production. You get massive cost savings from less waste and fewer operations. That right there is a powerful, powerful competitive advantage.
You know, ultimately, this technology forces all of us to ask a totally new kind of question. It's a fundamental shift from a subtractive mindset, cutting away what you don't want, to a formative one, commanding the metal to become exactly what you need it to be. So the real question is your shop ready to make that shift? Thanks for watching Die Hard American Metal. We'll see you next time.